Hello guys, this is Arman, and today I'm not going to solve any codes. I'm just gonna show you something interesting. So here's the problem. It's a Fibonacci array problem. We've already solved about the Fibonacci, so there's nothing. It's a pretty basic problem actually, but there's a trick here that all the Fibonacci numbers calculated in this program must fit in a unsigned 64-bit number. So here they have put it in a restraint and put it in a constraint. So this thing here is a bit tricky. So like you have written a program with integers and your program runs perfectly fine. So and you have like tried the program, ran the program, it works fine in your compiler or whatever. So but you submit the program and then it says that it doesn't match all the test cases. Maybe there are several test cases. Okay, when you're in a programming contest or whatever, and or you're just solving problems online in online judges, so there are several test cases, like 10 to 12s or 20s, hundreds of test cases. So it has to match all of them. So when in the cases of test cases, there are best case scenarios, average case scenarios, and worst case scenarios. You have to think about all of them. So we're not gonna talk about test cases here. We're just gonna think about this thing, unsigned 64 bits number. Okay. So let's say we have integer here. Okay. So in this code, you can see there's for I have declared this unsigned long and for the first, second, and nth. If you have seen the code for this, you know how this happens. But still, I'm going to explain a bit. So they want the test cases for at first I've taken the test cases as input. Then there are several test cases, and that's why I have taken x as an array, and inside a for loop I have taken the input for x. Usually I do my work over here, but I won't do it here because I'm gonna directly output it and call the function. I've used a user-defined function here, and I've called this function here on the output loop. If you have seen other videos, you see that this is my working loop and this is my output loop. Usually up until now I've just used 2 loops or something. So here this is my output, and in the output there's a loop for all the test cases. I run test case, and I have just called this function for Fibonacci. So everything here is fine, right? Unsigned long and everything, it works. It's perfectly fine. But what I'm going to try to show you here is this unsigned long. So as and just put one test, there will be one test case and number will be 45. And this is here is correct. How you can see that is we have a calculator, online calculator here, 45, and if you put it here, they are similar. They're absolutely the same. So it's correct. But if we go and put a value like, let's say 46 or 47, 46 here is correct. I don't have to look it up. But 47 here, there's a minus here, and instantly we know that this is incorrect. So what happened here? What happened here is it went out of bound. The capacity that it has, the variable that's containing the result, so it went out of bound. So what happened? We're returning nth, and nth is declared here as unsigned long. That is 64-bit, and that's into multiplied by 2 because this is unsigned. Okay, so what is happening here? is happening is that we're returning nth, but our return type here is integer, right? It's integer. So that's a problem, right? So that's what we should have done. Unsigned long. So we've got to keep track of this. So this here, the return type and this value type must match. Even if it doesn't matches, it won't be a big problem, because it's going to be like if it's inside the bound of the return type here. When you're printing this is an unsigned long, and this is an integer. So the return type is integer, so it's going to be downcast. So when it's a downcast, it's ultimately an integer. It's not an unsigned long anymore. Okay, so if it's like we were printing 45, up until 45 it was okay. If we had worked up until 45 it was okay, but when it's a bigger number than that, outside the capacity of integers, and the whole thing breaks down. Okay, so now I'm going to show you something else, like that I've told you, like there will be a problem. If there's a mismatch, there will be a problem, right? I'm going to show you an example of that. Let's take 6 test cases. 0, 1, 2, 3, 4, 5. Okay. So as you can see, the 0, 1, 2, 0, 1, 1, so it's a correct, it's all correct values. But shouldn't there have been a problem? Like here, this integer that we have initialized as integer, this n here is initialized as integer. And if n is 0 or 1, we're returning this n. So the program, this user-defined function, this function here is returning n as integer. And here is integer, but the return type here is unsigned long. This is a mismatch. There should have been a problem, but there is no problem. That's what I've told you. If there is, when it's an integer here, you're returning an integer, and it upcasts. It's like it upgrades itself. It upgrades itself to an unsigned long. So there is no problem here. Now, for the last part, I'm going to show you something interesting again. Let's say we have one test case. It's a -1. Bam! The whole thing broke down. Right? The whole thing broke down. It's showing a garbage value, a huge long value that we've never, like, what the hell. So why did this happen is because this is an integer, okay, and this is an unsigned long. Now, integer can have minus values, negative values, and positive values, but an unsigned long cannot have, or can only have positive values. So when you're trying to get a negative value, an integer can keep it, but an unsigned long cannot hold that negative value. So this is a major issue here. So if we did not have this unsigned thing, if it was just long, it would still be a mismatch, but still now it can hold the signed numbers. So if we try to keep -1 here now, it can keep a -1. Thank you guys. Hope you have enjoyed the video. And if you have anything to ask, you can ask in the comments below. Hope you have a good time.